This is R.D. Sharma Solution, Class 12, Chapter 19, Exercises 19.8, Indefinite integrals we are talking about. 1 by under root 1 minus cos 2x dx. Now we are dealing with the integral as well as the trigonometry. So you know the formula about this because we are going to use 1 minus cos 2x, 1 plus cos 2x, 1 minus cos x, 1 plus cos x, all these formulas. So you need to understand it very well. 1 minus cos 2x is equal to 2 sine square, whatever the angle is on the left hand side, the right hand side the angle will be half. So 1 minus cos 2x will be 2 sine square x, and 1 minus cos x is 2 sine square x by 2 likewise. So let us start the integration here. We have 1 by under root, let me write this 2 sine square x here. So this is 2 sine square x and this is dx. So this is root 2, 1 by root 2 we can take outside. Under root sine square means sine because square and root cancels out. So 1 by sine x it is, an integration of dx. But you know that 1 by sine x is simply cosec x. This you already know. As 1 by cos x is sec x, 1 by tan x is cot x, 1 by cot x is tan x, like that. So 1 by sine x, let us write it as cosec x because we have the direct integration of cosec x. So 1 by root 2 here, I am writing cosec x in place of 1 by sine x, but integration of cosec x is known to us. It's a standard result. If you go back and revisit my previous discussions, we have already proved it. So let us write it. This is ln. ln is log to the base e. Log to the base e. How about modulus? Modulus is important. Cosec x minus cot x plus constant of integration. This is your result. Alright. So let me resolve this. This place you can stop. But in order to make it more simpler, we will make it 1 by sine x. Cot x is cos x by sine x. So this will become 1 minus cos x divided by sine x. So this 1 minus cos x is what? As I told you in the very beginning, it's 2 sine square, whatever angle is there, divided by 2. So 2 sine square x by 2 for 1 minus cos x, sine x can be written as, because sine theta is 2 sine theta by 2 cos theta by 2. Because sine 2 theta is 2 sine theta cos theta. So 2 sine x by 2 cos x by 2, whatever is getting cancelled, only 10x by 2 is remaining. 2 gets cancelled, sine and sine gets cancelled. So you have 10x by 2. So we have 1 by root 2. So I am writing it here now. Because ln is already there, modulus you cannot forget. So 10x by 2 under modulus plus the constant of integration. This we have already proved, cosec x minus cot x. It came out to be this. So this is the result which we are talking about. So we always tend to discuss all the formula which we are using or which we should use. Same thing here. 1 plus cos x. What is 1 plus cos x? It's integration of 1 by under root 1 plus cos x, as we have just discussed. I'm writing it directly. It's 2 cos square x by 2 dx. 1 by root 2 you can take it outside. Cos square x by 2 is simply cos x by 2. And 1 by cos by 2 x by 2 is sec x by 2. That is under root cos square x by 2 is cos x by 2, as we just discussed. And this is 1 by cos x by 2, so it will go up and it will form sec x by 2. So we have sec x by 2 here. Integration of sec x by 2 dx. So there is a standard result which we already talked about in our earlier discussions. So we are going to use the direct result of the integral here. So this is 1 by root 2. And please remember one more thing here. I'll just tell you in a while. First, sec x by 2 is simply tan x by 2 because it's a standard result. Tan x by 2 plus sec x by 2. We have this inside ln, which is log base e, and covered by the modulus plus constant of integration. But one more thing is remaining because x by 2 is there. There is an algebraic expression. You have to differentiate it and the result needs to be divided. Divide dx of x by 2 is 1 by 2. 1 by 2 has to be in the denominator. So 2 goes up. So 2 by under root 2. You can stop here, but the examiner and the R.D. Sharma wants us to make it more easier. Well, for me, it's easiest. This is the final answer. But in R.D. Sharma solved questions, they have more simplified it. So we'll do that. Tan x by 2 plus sec x by 2. Let us take this separately and try to resolve it. Tan x by 2 is simply sin x by 2 by cos x by 2. Sin theta by cos theta. Plus sec x by 2 is 1 by cos x by 2. Now since the base are same, the numerator becomes 1 plus sin x by 2 divided by cos x by 2. So we'll apply this formula here. 1 plus sin x by 2 by cos x by 2. Now this sin, see, first thing is 1 can be written as sin square theta plus cos square theta, because sin square theta plus cos square theta is equal to 1. How about sin x by 2? You know that sin 2 theta is 2 sin theta cos theta. So sin x by 2 is 2 sin x by 4 cos x by 4. Whatever the angle is, it will become half. So we have sin square x by 2, which is half of x by 2, which is x by 4. Cos square x by 4, because angle is sin x by 2, which will eventually form 2 sin x by 4 and cos x by 4. So we have to match it with the 1. So sin square x by 4 plus cos square x by 4, we have introduced ourselves in place of 1. So what do we get? This is a square plus b square plus 2ab. So this is nothing but a plus b whole square. A square plus b square plus 2ab. So this is sin x by 4 plus cos x by 4 whole square. So what we have done is 1 we have replaced as sin square x by 4 plus cos square x by 4. Sin x by 2 we have replaced as 2 sin x by 4 cos x by 4. So let me write it here. 1 sin square x by 4 plus cos square x by 4. And of course sin x by 2 is 2 sin x by 4 cos x by 4. So I've told you 3 times, I guess. So this is now clear to you. Coming now to the denominator. We have to do something with cos x by 2 also, because the r.d.sharma wants us to do it, because for me ln tan x by 2 plus sec x by 2 is the final answer. But let us do it. What is cos x? You know it. It's cos square theta minus sin square theta by 2. So cos theta is cos square theta minus sin square theta. So cos theta will be cos square theta by 2 minus sin square theta by 2. So this cos square theta by 2 minus sin square theta by 2 is simply a square minus b square. And it can be written as a minus b plus a plus b. So cos x by 2 is cos square x by 2 of 2. Half of x by 2 is x by 4. So cos square x by 4 minus sin square x by 4. Now this is a square minus b square, a minus b into a plus b. Multiply this 2 by root 2 by root 2 and root 2, numerator denominator. So what are you going to get? You will get only root 2. So the numerator becomes sin x by 4 plus cos x by 4, this whole square. The denominator is cos x by 4 minus sin x by 4 plus cos x by 4 plus sin x by 4. A square minus b square is a minus b into a plus b. So cos x by 4 minus sin x by 4. And here we have cos x by 4 plus sin x by 4. So there will be a cancellation. What will be cancelled? Sin x by 4 plus cos x by 4 is common in numerator and denominator. So this is your final result. You can just cancel it out, or you can just keep it like that. This is what book wants us to portray. That's why we have done it. So this is what you have to do. All the formula we have discussed, I think, multiple times now. Just I want it to be get feeded into your mind. 1 plus cos 2x, 1 minus cos 2x, already done question. Let us do and write the formula directly. 1 plus cos 2x, 1 minus cos 2x. 1 is, so let me write it, and you'll see it will become so easy. 1 plus cos 2x is simply 2 cos square x by 2. 1 minus cos 2x is 2 sin square x by 2, which is 2x, so the angle will be x only. So 2 cos square x, 2 sin square x, inside an under root and integral. 2 gets cancelled, cos square cos, sin square sin. So cos by sin under root, which is under root gets cancelled. So you can just eliminate the under root. Cos by sin is only, it's cot x. So you are essentially integrating cot x. And there is a standard formula for cot x. What is the formula? It's ln, that is log base e, modulus of sin x plus constant of integration. So this is how we are going to write it. Okay. So this is a repeat telecast, same question with a different x angle only, means theta angle. 1 minus cos x is 2 sin square x by 2. 1 plus cos x is 2 cos square x by 2. So 1 minus cos theta, just to remind you, just to recall those things which we have learned. 1 minus cos 2x is 2 sin square x. 1 plus cos 2x is 2 cos square x. Because whatever the angle is on the left hand side, the angle on the right will be half of it. So let us do it. This is, so 1 minus cos x is 2 sin square x by 2. 1 plus cos x is 2 cos square x by 2. So let me write it here. 2 sine square x by 2 divided by 2 cos square x by 2, and this is inside your under root. So square root gets cancelled. 2 gets cancelled already. So you are left only with 10x by 2. Sin x by 2 by cos x by 2 is 10x by 2. Sin theta by cos theta is 10 theta. Now we are going to integrate this. When you integrate this, it's the result which is minus ln log base e. What is 10x by 2? It's simply cos x by 2. Please remember, when we were integrating, it is sin x by 2 by cos x by 2. Cos x by 2 will take t, then differentiate it. Sin x by 2 will be replaced, and that is how 1 by t will be there. 1 by t, 1 by cos x by t is log only. So that's how it has come. But we are not stopping here. There's one more thing. Modulus you are not going to forget. One more thing. X by 2. What is x by 2? See, first of all, ln has to be there. You cannot write log. Modulus should be there. That has to be kept in mind. But one more thing is there. When you integrate something like trigonometric expression, the inside x by 2 has to be differentiated, and that has to be divided. That is, x by 2 has to be differentiated. It's going to give you 1 by 2. That 1 by 2 goes in the denominator, but essentially it will go up. This is your final result. So this is what I was talking about. It's a very simple question. If you understand or recall these formulae, this question will be very simple to you. Evaluate the following integrals. Sec x by sec 2x. Let me resolve it. Let us find an expression which we can easily integrate. For that we have sec x by sec 2x. Please remember, cos x is simply the inversion of sec x is inversion of cos x, and cos x is inversion of sec x. So 1 by sec x can always be written as cos x. 1 by sec 2x can be written as 1 by sec 2x is 1 by cos 2x. So this goes up. 1 by sec x is 1 by cos x. 1 by the sec 2x is 1 by cos 2x. So cos 2x goes up. Cos x comes in the denominator. Cos 2x is 2 cos square x minus 1. Cos x in the denominator will remain same. 2 cos square x minus 1 can be separated with the cos in the denominator. This cos gets cancelled. So you just have a 2 here. This is what will be here. Only one cos will remain, 2 cos, and 1 by cos x can be written as sec x. Now let us integrate. Cos x is simple. Sec x we already know. We have already done a question like this. So it will be 2 cos x is sin x. There is no differentiation of x that can be put in the denominator. So we'll just go for sec x. It's ln modulus sec x plus 10x. So even if we differentiate x, 1 will be there. So no point in writing it in the denominator. This is your final result. See, this is all resolving. Integration is this one. Okay, this is your final result. This is how you're going to write it. These are all the steps which we already explained. Now this question, cos 2x divided by cos x plus sin x whole square. Now we have the direct formula for cos 2x. So we'll try to get cos x plus sin x from cos 2x. Because cos 2 theta, what is the formula? It's cos square theta minus sin square theta. That you already know. This is what we are going to use. Denominator we have cos x plus sin x whole square. Now this cos square theta minus sin square theta is actually a squared minus b squared. So cos 2x is essentially cos x minus sin x into cos x plus sin x. Because it is cos square x minus sin square x. So a minus b, a plus b, that will come. Okay, let us integrate now. So we have cos x plus sin x, and here we have cos x minus sin x. In the denominator we have cos x plus sin x ka whole square. So what we got from cos 2x is a term which can be cancelled out with the denominator. So we have cos x minus sin x in the numerator, cos x plus sin x in the denominator. And please remember this question because there are multiple questions of the same sort which are coming in the later part. So take this cos x plus sin x equals to t. When you differentiate this, what do you get? Cos x is minus sin x. Sin x is cos x. So we have negative sin x plus cos x, and this is equal to dt by dx. Now take this dx on the left, that is cross multiply. What do you get? Actually, it's cos x minus sin x into dx equals to dt, and this cos x minus sin x into dx is already there in the numerator which you see here. So from here to here is actually dt. So let us replace this by dt because cos x plus sin x we have already taken it as t. So this is how it will go. The numerator becomes dt, the denominator is t, so it's all about log. So take ln log base e basically plus, and this is constant of integration, and ln modulus of t. Please remember modulus is essential. So you have ln, this is cos x plus sin x plus constant of integration. This is your answer. So this is the result I was talking about, and this is the way you're going to write it. It's a neat and clean thing because when I actually explain you, I give you all the options what we have used. Now this kind of questions, remember, there is a trick, or you can call it as a tip. See, always we try to take the denominator as something so that the numerator can be changed. Here we have in the denominator x minus b. X minus b is what? It's t. That is what we have imagined, assumed. So what will be x? Because x you have to replace it in a short while. Now we need to differentiate both the sides. So 90% of the time this denominator is taken as t, some part of the denominator or whole denominator. But 10% of time the things may change. So this x minus a in the numerator will become what? It's actually x is b plus t. So b plus t minus a, which is b minus a plus t. So you can call it as b minus a plus t or b plus t minus a. Denominator is what? Sin x minus b. So x minus b you can take it as t, sin t. And this is dt of course. Why dt has come? Because when you differentiate x equals to b plus t, dx will be equal to dt. That is why dt can be replaced by dx. How about this? I assign b plus t minus a. Let us take b minus a separately and t separately. And now apply the formula of sin a plus b. That is b minus a, I am calling it as a capital A. T I am calling as capital B. So sin a plus b. What is sin a plus b? Sin a, you know the formula, right? Sin a, which is b minus a in this case, cos t plus cos a, that is cos b minus a, and sin t. So we have applied the formula. Sin t is in the denominator, so just include this sin t in the denominator. So what do you get here? This gets cancelled. Please remember sin b minus a and cos b minus a, they are constant. They don't have any variable, neither t nor x. So sin b minus a can be taken outside. Cos t by sin t is cot t, C-O-T, cot t. So I am taking this sin b minus a, which is essentially a constant. Integration will only happen for cot t. How about this one? Cos b minus a. Cos b minus a is again a constant because b minus a has no t, no x. And integration of dt, because nothing is inside, so only x, dx we generally do, means x will come. So here integration of dt will, the t will come. So cot t has a direct integration. I've already discussed it with you. It is ln sin t with a modulus. Cos b minus a remain like this. Integration of dt will be t only. So cos b minus a into t. This is the whole integration result with a constant of integration. But it's not complete because t you have included by yourself. Nobody told you to do that. The question is only asking about x. So you have to convert now t to x. So wherever t is there, just replace it by x minus b. So it will be modulus of sin x minus b, this plus t, and t will be replaced by x minus b, and this will be cos b minus a plus constant of integration. This is the whole thing. So t will be equal to x minus b that we have replaced. This is your final answer. So this is what I was talking about, and this is the way to write everything. Clearly, this is the way you need to put it on your paper with your pen. Now sin x minus alpha by sin x plus alpha. Again same thing. From previous experience we have learned most of the thing or most of the assuming is done for the denominator. So x plus alpha. Let me again reiterate, most of the time this is the case, but don't take it as every time. 10% time you may not be able to, or you will not take the denominator as t. But here the question is very simple. So x plus alpha is equal to t, x becomes t minus alpha. when you differentiate it, dx by dt is equal to 1. And you take this on the right, so dx will be dt. How about integration? See, x minus alpha. What is x? T minus alpha. So t minus alpha minus alpha. T minus alpha is t minus 2 alpha. So this goes up t minus 2 alpha. In the denominator, what do you get? Again, sine is already there, but because x plus alpha was already t, so sine t minus 2 alpha by sine t, this is dt. Now sine a minus b, if this formula is known to you, you can proceed with the solution. Sine a cos b minus cos a sine b. This is the formula of sine a minus b. Sine a cos b minus cos a sine b. So now you have the denominator sine t already. So there will be cancellation on the first part, the first term. So cos 2 alpha is simply a constant. Please remember alpha is a constant. So cos 2 alpha integration of dt minus this sine 2 alpha comes out. Cos t by sine t is cot t dt. So this is cos 2 alpha. Integration of dt is t only. Sine 2 alpha. Cot t has a standard result. What is the standard result? It's ln, that is log base e, modulus of sine t plus constant of integration. Now just replace this t by x plus alpha. Wherever you get t, x plus alpha has to be replaced by wherever t it is. So x plus alpha for t, cos 2 alpha was already there. Sine 2 alpha in this case, ln, and sine in place of t, just write x plus alpha. Because t we have included ourselves. And this is constant of integration. This is your final result. Alright. So this is the result I was talking about. And this is the clean step-by-step reproduction of whatever we have seen just now. I explained you. Now what do you see here? 1 plus tan alpha and 1 minus tan alpha. You'll see a similar question we have just completed. Okay. So we will try to make it so that it becomes easy. Because if you place 1 minus tan alpha equals to t, you are not going to get anything. So there should be some other way. What will be the another way? Tan alpha can be replaced by sin alpha by cos alpha, because tan alpha is nothing but sin alpha by cos alpha. Same thing I've done here. Now cross multiply. This is cos alpha. This goes here plus sin alpha. And then 1 into cos alpha is cos alpha. Same thing, cos alpha into 1 cos alpha. Sin alpha into 1 is sin alpha minus sin alpha divided by cos alpha. Now you can just cancel this cos alpha. Okay. So this is the same question which we have completed just now. Cos alpha plus sin alpha, cos alpha minus sin alpha. Now, those who have already, are comfortable with the previous question, they can just go about it. Means they can just move forward. And what we will do here is, we are going to complete it. See, this way the question is formed. Cot t plus 1 and cot t minus 1 has the same scenario, same solution. But I'll show you a question where same thing will have a different solution. You'll just see. So there are some catches which you have to actually catch in the boundary, on the boundary line. So cos x minus sin x equals to t. Let us differentiate. It will be minus cos x equals to dt. Dx goes up. So you have to cross multiply. So what do you get? You get minus sin x plus cos x, because negative I have taken outside. So sin x plus cos x will be there. Dx will be equal to dt. So this whole content is equal to dt. So you can call it as sin x plus cos x into dx is negative dt. So just write it as a negative dt. So you have a negative dt divided by cos x minus sin x is nothing but t. So what is there? See, it's simply ln modulus of what is t? If you remember, cos x minus sin x was t. So just write it. I'm just trying to reduce one step. I'm writing it here only. Cos x minus sin x plus cos of integration. There is a negative. And this negative you can just keep, or you can make it more simpler if you want. This is your answer. So this is how we go about it. 1 plus tan x, 1 minus tan x, cot x plus 1 cot x minus 1, same result, same solution. But there will be one question which will come just now, and I'll show you. Always the grass is not green. Okay, we have just done a question like this, completed this question. So this x minus a equals to t. Just put x minus equals to t, you will get something out of it. Okay, let's try it. This is the trick. Means whenever you have something which is like this and you cannot go about it, the best way is to try and check whether x minus a equals to t. If you put, we are going to get something out of it. Let's see. X minus a equals to t. X will be equal to a plus t. Now differentiate both the sides. So you will get dx equals to dt. Because a is a constant and because we are differentiating with respect to t, it will be dx by dt equals to 1. So dx will be equal to dt. That we are going to use just now. How about this cos x? See, x is a plus t. So cos a plus t it will be. This x I have just written for your sake. You just need to eliminate it. Same here, cos x. In place of x, you are going to write t. So cos a plus t we are talking about and cos t we are talking about. It's not x. I've just written it for your for saying that x is a plus t and here x is t. So cos a plus b formula, cos a cos b minus sin a sin b, that you already know. Cos t is already there in the denominator. So this x will not be there. Numerator also you can just cancel it out. Okay, cos t here. Now let us integrate this in terms of dt, in terms of dt. Cos t gets cancelled. Cos a is a constant. So cos a you can just take it outside. Integration of dt will be t. Here sin a you can take it outside. Sin t by cos t is tan t. And integration of tan t has a standard result. What is the standard result? You already know it. So let's just make it simpler. T cos a minus sin a. It's ln modulus of something. If you remember. See, sin t by cos t is tan t. So when you put cos t equals to t, you will get the required result. That's why you can remember like that. So ln will be ln modulus of sec t. Now just replace x wherever it is. So t content has to be replaced. So t is x minus a. So x minus a into cos a minus sin a. Ln sec t is sec x minus a plus constant of integration. So this has become so easier. So this is the result I was talking about, and it's a clean version, a printed version for you. Now, as I was talking about these previous questions I just mentioned, that you will see that all the questions of the same sort will not lead to a similar answer. Because you know sin square theta plus cos square theta equals to 1, that what we are going to use it here. So in place of 1, I am writing sin square theta plus cos square theta. Now this is minus, what is sin 2x? Sin 2 theta is 2 sin theta cos theta. That you can use. So sin 2 theta is 2 sin theta cos theta. Just write it as 2 sin x cos x in this case. In the denominator, again, 1 is sin square theta plus cos square theta. I am just taking root on separating this root because I just want to show you that something square will come and we can cancel this root and square just now. 1 again will be replaced by sin square x plus cos square x. How about sin 2x? Sin 2x is 2 sin theta cos theta. So I am writing 2 sin theta and cos theta here. But what is the formula? A square plus b square minus 2ab is a minus b whole square. A square plus b square plus 2ab is a plus b whole square. You already know that. Cos x minus sin x, you can write it as sin x minus or cos x also. But don't worry about that. You'll see why I have written this cos x minus sin x. I have not taken sin x minus cos x. Okay, you'll just see. So cos x plus sin x whole square in the denominator. This root gets cancelled with a square. So you are only left with cos x minus sin x divided by cos x plus sin x. Now just go back to previous questions we have seen. This you can solve it easily. But the answer with the approach we are going to take just now is different. You'll just see that it's not always that you do the way others are doing. Sometimes everyone has a neural network which thinks differently, right? So you will think differently here. One more way, because previously cos x plus sin x we took it as t. Then we differentiated. We differentiated cos x minus sin x came upstairs, that is in the numerator. That's how we got log. But here I am dividing whole numerator denominator by cos x. So cos x by cos x is 1. Minus sin x by cos x is 10. Cos x by cos x is 1. Sin x by cos x is 10. So 1 minus 10x divided by 1 plus 10x. And then you will integrate. And you have to remember or recall one formula. Tan a minus tan b by 1 plus tan a tan b is tan a minus b. Remember? 1 is nothing but tan 45 degree, or you can call it as tan pi by 4. So tan pi by 4 is equivalent to 1. So just write in place of 1 tan pi by 4. In the denominator 1 plus tan x is there, so multiply it with tan pi by 4. Now formula becomes tan a minus tan b 1 plus tan a tan b. A is pi by 4, b is x. So tan a minus tan b by 1 plus tan a tan b becomes tan a minus tan b, tan a minus b actually. So it's 10 pi by 4 minus x dx. What is the integration of tan? Sin x by cos x. So cos x equals to t. So log will come. So log 1 by cos x is sec x. So sec pi by 4 minus x. Okay. So this is a different approach for the same question we have already done in this exercise. But the answer has not come as of now, not yet. Because pi by 4 minus x has to be differentiated. When you differentiate it, negative 1 will come and that has to be divided. When negative 1 division or multiplication remains the same. You already know that. So negative is already there. You can keep it like this, but we never keep or we don't keep negative outside. Sometimes we may keep if there is nothing possible. But here there are certain things which we can do with this. See, a log b is nothing but a log b raised a. So this negative goes to the power of sec pi by 4 minus x. And you know that x raised minus 1 is 1 by x. So we have ln 1 by sec pi by 4 minus x plus constant of integration. Now what is 1 by sec pi by 4 minus x? It's cos pi by 4 minus x. So the final answer is ln, that is log base to e, cos pi by 4 minus x, always in the modulus, that is very important, plus constant of integration. So this is all about this question, the different approach we have taken. You can take the previous approach also, there is no harm, but just to know that same question can lead to different answer, or the presentation of the answer can be different way, in a different way. So you need to be very careful about this. Now this one, e raised 3x by e raised 3x plus 1. We know that the differentiation integration of e raised x is e raised x only. Now what we do is, the trick is we always take the denominator and we take it as t, differentiate it and try to get the numerator out of it. For example, if you take t as e raised 3x plus 1, which is the denominator here, when you differentiate it dt by dx, what are you going to get? E raised 3x will be e raised 3x only. And differentiation of plus 1 will be 0. And differentiation of 3x also has to be done, and that 3 has to be written. So dt becomes 3 into e raised 3x dx. Now in the numerator you see e raised 3x into dx. So e raised 3x into dx can be written as dt by 3. So the numerator now in terms of t becomes what? dt by 3. So dt will write it here. 1 by 3 will take it outside the integral sign. And this denominator of course was t. So keep it as t. Now how easy it is now. Log, that is log base e, ln we write. Modulus of t plus constant of integration. 1 by 3 will be there outside. Now this t was actually e raised 3x plus 1, which we let or supposed in the earlier period of time when we started this question. So 1 by 3 ln e raised 3x plus 1 plus constant of integration. This is your final result or answer. So this is how you're going to go about it. Whatever we have explained right there. Okay, 3 sec x plus 5 in the denominator. In numerator we have sec x tan x. And we know that the differentiation of sec x is sec x tan x. So you can see that how the things unfold. Sec x, if you put it as t, I'll show you one more question where it's not necessary to put 3x, this sec x equal to t. You can have 3 sec x plus 5 also. You'll just see in a later question. Right now sec x equals to t, dt by dx is sec x tan x. So dt will become sec x tan x into dx. What do you see here? This is nothing but the numerator. What do you see here? Numerator, denominator was 3t plus 5. So it's a form of ax plus b integration. And you know already what is the differentiation of that. So let me write sec x tan x dx as dt. The denominator is 3 sec x plus 5. For that we have 3t plus 5. So just imagine that this is dx by 3x plus 5. So we have a direct result out of it. So 1 by 3x plus 1. If you assume it like this, 3x plus 5, sorry. So the result will remain the same, ax plus b. So this will be ln 3t plus 5 plus 5. Don't stop here, because 3t plus 5 has to be differentiated. And whatever the result is has to be divided. So 3t plus 5 d by dt, just do d by dt out of it. So when we do this d by dt or differentiation with respect to t, this is going to be 3. So this 3 has to be divided. So 1 by 3, what was t earlier? It was sec x. So it will be 3, in place of t, just write sec x plus 5 and then the constant of integration. So t is sec x here. This is your solution. So this is what we were talking about. So you can take 3x, see 3 sec x plus 5 equals to t also. We'll just see in one of the questions coming up. If you remember, this cot x minus 1, cot x plus 1, 1 minus tan x, 1 plus tan x, cos x minus sin x by cos x plus sin x, sin x minus cos x by sin x plus cos x, all of them have the same way of proceeding with the solution, exactly similar. One of the question we have earlier tried, and we tried to give you another answer, a different approach, but the basic approach remains the same here, which you see here, and you will recall, once I will come to that point, you will recall, I am sure about this. Cot x can be written as cos x by sin x, so 1 minus cos x by sin x, denominator becomes 1 plus cos x by sin x. Okay, so just take the denominator or the LCM and sin x. So sin x goes here, cos x goes here, sin x remain in the denominator. Now coming to the denominator, actual denominator, sin x plus cos x divided by sin x. So this sin x gets cancelled. So you have sin x minus cos x divided by sin x plus cos x. Okay, can you decipher something? Decipher, I should say. See, this sin x plus cos x, if you put it as a t, this dt by dx will give you sin x will be cos x will be minus sin x. Alright? Sin x is cos x is minus sin x. But you have sin x minus cos x in the numerator. So you ought to get this sin x minus cos x from there. So let us take a negative outside from here. So you can make it as sin x minus cos x with a negative sign outside. Dt by dx is here. Now this negative goes on one side and dx goes here. That is, negative dt is nothing but sin x minus cos x dx. So if you just remove these, just consider the top sin x minus cos x and the bottom sin x plus cos x. So what do you get here? See, sin x minus cos x into dx is minus dt. We just found out that thing. Sin x plus cos x we originally kept as t. So what is the integration? Integration is simply ln modulus of t. Negative will remain there. If you can take this negative inside and do something, simplification you can do, then it's okay. Otherwise just keep negative outside, it's not a big deal. So we have t here, and remember what was t? T is sin x plus cos x. So you have a negative outside, then we have a ln sin x plus cos x, and then the constant of integration. This is what you see is the correct answer. So this is the solution I was talking about. What do you see here? Same thing, the different questions which I just spoke when I started this question, all of them are solved in the same way. Sec x cos x log tan x dx. Please remember this log tan x or log x, this log is base e. So I am writing log, but basically ln is log base e. But we can change, we can use this interchangeably. So what do we have? T equals to log tan x, the denominator. Normally we keep it as t. Dt by dx will be log tan x is 1 by tan x. Tan x will be sec square x. Okay. Sec square x, see, it will be 1 by cos square x. This sin x cos x, sin x will remain here. Cos goes up. 1 by 1 cos gets cancelled. So you have 1 by cos x by sin x. So it will go up. And when it goes up, you are going to get this sec x cosec x. That's what we wanted, right? So this goes up, cos goes up, becomes sec x. This sin x goes up, it forms cosec x. And sec x cosec x into dx is what we wanted, and this has become dt. So the numerator, you can just keep it as dt. So this is the integration, dt divided by this is whole is t, and this is a d. You don't have to write anything, dt is already there. So this will be ln or log, because we have initially said that's ln only, log base e. The log base e, then take the modulus, and this is log of 10x. And then you have this, because it was originally t, which we imagined. This is your answer. So the direct answer, see, I just removed one step, which is dt by t is log modulus t plus c. Then we go to that answer. So this is what we were talking about, right? Next one is 1 by x into 3 plus log x dx. So this log x differentiation is 1 by x. You already know that. So 1 by x dx you will directly get from here. But how about keeping 3 plus log x as t? That can also be done. T equals to log x or t equals to 3 plus log x. It's up to you. Both can be taken as t. When you differentiate dt by dx, it will be 1 by x. So this dt will become dx by x. So dx by x is already there. So just keep or put this dt here. So this is integration of dx by x is dt, 3 plus log x, 3 plus t. If you would have done 3 plus log x also as t, same thing you have got. Okay. So dt by 3 plus t, this is a form of say 1 by x plus b. A is 1, b is 3 here. So log 3 plus t plus constant of integration. So you have log here in place of 3 plus t, you can replace it by log x plus constant of integration. So only 2 steps we have used. See, this was so easy. The only thing is, if you know the trick that 3 plus log x gives you dx by x, that solves the issue. This is the result we were talking about. So you just have to follow this. Now see here, you see if you take 3 e raise x plus x equals to t. If you take t equals to e raise x plus x, directly the numerator will come. So dt by dx will be e raise x will be e raise x only, and this x will be 1. So this is what we wanted. So dt will be e raise x plus 1 into dx. Now this you can just replace it by dt. So numerator becomes a dt here. The denominator is e raise x plus x, which is t, and the result will be log modulus of t plus c, ln basically log of t plus c. It will be ln. What will be t? This t you kept or assumed it to be e raise x plus x, so just replace it by e raise x plus c. This is your answer. So what is the result? This is your result. Okay. Now this is quite straightforward for you. Log x gives you directly 1 by x. So just take log x as t. Dx by x will automatically come. So I'm now equating t as log x. Dt by dx will be log x will be 1 by x. Dx you can take it on the right hand side. So dt will become dx by x. So this one which I'm pointing out, making a region, and that region is simply dt. So you have a dt here, t in the denominator. Log x we took it as t. It will be directly log base e modulus of t plus constant of integration. They follow the same routine which we have done for the previous 3-4 questions. So log modulus of t plus constant of integration. T replaced by log x because you have introduced it by yourself. So log x, log x, but it has to be inside the modulus plus constant of integration. So this is how it will be made. So just write this here, putting all this you have to write by yourself. All the symbols, make it proper, right? Now sine 2x divided by a cos square x plus b sine square x. So let's divide and conquer. We know that this sine 2x is 2 sin x cos x. We'll try to get this 2 sin x cos x or at least sin x cos x per se. So let me write it in order to actually let you know that sine 2x is 2 sin x cos x, which is known to you. And even if we get sin x cos x, that will solve our purpose, because we now need 2 sin x cos x dx in the numerator, or sin 2x into dx in the numerator. But putting what? Placing what? If you see this sine square x, if you differentiate it, it will be 2 sin x, then sin x will be cos x. So if you put this sine square x as t, you are going to get this. So I'm replacing cos square x by 1 minus sine square x here. And this sine square x will be same. So wherever we have cos square x, I'm replacing it by sine square x. So this sine 2x in the numerator, a into a minus a sine square x plus b sine square x. So just keep those sine square x terms together and other terms separately. That is, if you multiply this inside, I'm talking about the denominator, it will be a minus a sine square x plus b sine square x. So I'm taking this b and negative a with sine square x together. A is a separate constant, so I'm keeping it separately. Now let us take sine square x as t. You see what will happen. dt by dx will be 2 will come front, sin x, then differentiation of sin x will be cos x. So dt will be 2 sin x cos x dx, which is basically sin 2x dx only. So this sin 2x is nothing but 2 sin x cos x, this whole is already dt. So 2 sin x cos x, you can just write it like this. b minus a sin square x plus a. I'm trying to show you that this sin 2x is nothing but 2 sin x cos x, which we have retrieved from putting t as sin square x. So this is dt by b minus a. Sin square x is t, it's not t squared, it's t, plus a. Okay, now again, simply the same discussion. dt by or dx by 1 by dx by ax plus b. Let me write it. Integration of 1 by ax plus b dx is simply 1 by a log base e modulus of ax plus b. This we have already done in several questions. I'm just trying to make it formal now. So this 1 by a, what is a here? B minus a. Just follow this one, okay? That was right one, was just the formula, but we have to follow this. ln b minus a into t, because this is plus a plus constant of integration. Now just one thing you have to do. T was sin square x, just replace t by sin square x. And that will formulate your final result. So 1 by b minus a, this is ln, and you take the modulus b minus a into t will be sin square x plus a, which is constant of, constant of integration has to be put in the end. One more thing you can do. See, 1 by b minus a was already there. Now b minus a into sin square x plus a. So b sin square x minus a sin square x plus a. Now, how we combine this a and a? That will be better. You can keep it like this, but just for the sake of completion, it will be b sin square x, and you take just a common from here. When you take common here, it will be 1 minus sin square x. 1 minus sin square x is cos square x only. So what do you see here? The denominator has come already. This is the denominator of the actual question, which has come in the ln. So this is the way you are going to go about it. And practice will make you more comfortable when you solve this question in the later part when you have actually exams of yourself. So this is how it goes. Now cos x by 2 plus 3 sin x. So this we can directly deal. I told you I'll come up with a question where I'm not going to write just sin x as t. I am going to put 2 plus 3 sin x equals to t. You'll see the same result will come. I told you earlier also that it's up to you, which makes your life comfortable. So rather than having just sin x equals to t, just put t equals to whole of the denominator, which is 2 plus 3 sin x. Now differentiate it. dt by dx will be 3 cos x. So this cos x into dx is what? Now multiply this. dt will be equal to cos x into dx, and this 3 will come in the denominator. So wherever you have cos x into dx, just write dt by 3. 1 by 3 you can take just outside the symbol of the integration, and dt divided by t. Now you know the standard result, which you have been doing for almost 20 questions now. So this will be 1 by 3 ln modulus of t. So what was t? You have to replace it by 2 plus 3 sin x just now. So 1 by 3 ln 2 plus 3 sin x, and then the constant of integration. This is your final result. Now knowing it and solving it are two separate things. I told you how to do it, but this is how you are going to actually write it, right? If you take sin x equals to t, this is the result. I took 2 plus 3 sin x as t. So the result remains the same, alright? There may be different paths, but the manzil is same. The result is same. 1 minus sin x divided by x plus cos x. Now if you watch this x plus cos x denominator very closely, you will find that the differentiation of the denominator is exactly the numerator. So t is equal to x plus cos x. If we put this, dt by dx is going to be 1. Cos x will be minus sin x. 1 minus sin x. So this 1 minus sin x into dx, if you take this dx on the right hand side, cross multiplication, what you find is the numerator is actually d when we take t, and denominator is x plus cos x, which is t. So dt by t, and this is simply log base e. So let us write it as ln modulus of t. What is t? T was x plus cos x. So let us write x plus cos x and along with the constant of integration. This is your final result. Now this is the way you are going to put this thing on a paper using your pen, and please write let, putting, all this has to be done. Now this type of question, there are a few questions of this same sort. Even if you write this b plus c raise ex into some t, you won't get anything in the numerator. But one thing is very clear, when e raise x comes, this e raise x differentiation is e raise x only. Integration also is same. So if you divide numerator and denominator by e raised to x, so I am dividing everything by e raised x, numerator, denominator included. So this e raised x, when it goes up, it will become e raised minus x. And there will be negative also when you differentiate. So with this trick we are going to apply here. E raised x goes up. This goes in the numerator, it will be e raised minus x. This is b, e raised x goes up, it will be e raised minus x. Then you have c, this you can just cancel these out, so only c will remain. So what do you get here? When you take e raised minus x as t, this dt by dx will be e raised minus x, and differentiation of negative x will be negative 1 or negative. So this, if you take this, let me write it so that I can show you what is the numerator and what are we getting when we put this e raised minus x equals to t. So e raised minus x into dx is negative dt. Just replace this by negative dt here. A you can take outside because it's a constant, and this negative also minus dt, so negative I'm taking outside. So dt divided by b, e raised minus x is t plus constant of integration. So we have this integration of 1 by ax plus b always gives you, this is very important in this exercise. It gives you 1 by a ln log base e modulus of ax plus b if ax plus b is only in the denominator. So just assume that a is b here, b is c here, and there is a conflict here which is the c, constant of integration. I'm just going to deal with it just now. So what will be the result? The b will go down, that is 1 by a as you saw in the actual formula. So this b goes on the denominator ln bt plus c. Now this c, if you are writing it, you have to write this constant of integration as the capital one. So almost done. Only t has to be, we have to get back to the original thing, which is our e raised negative x. So negative a by b ln b raised b into e raised minus x plus constant of integration plus this capital C, which is denoting the constant of integration. This is how you are going to write it, dividing numerator and denominator by e raised x, putting I, capital I, what you have written here, and since 1 by ax plus b integration is this thing, all this has to be written, right? So the next question is almost similar to this question. If you understood this, this one will be very easy to you. What we'll do here is, we will divide everything by e raised x. So e raised x divided by e raised x plus 1 by e raised x. What do you get here? E raised x goes up, e raised minus x. This gets cancelled, so you have 1 plus 1 by e raised x is e raised minus x. Now what do you get here? Just put e raised minus x equals to t. That's very obvious now, because previous question, if you followed it, this is dt by dx, e raised minus x. Differentiation of negative x is going to be negative 1. So we need e raised minus x into dx. So when you cross multiply, e raised minus x into dx is equal to negative dt, and the numerator is going to be negative dt. So e raised minus x into dx, it is negative dt, so negative comes here, dt, and 1 plus e raised minus x goes in the denominator, 1 plus t. And this already we have seen in the previous question also, that it's a simple integration result. I is equal to, let's write the result, it's just ln, that is log base e, negative was outside already, 1 plus t, this goes up, and with the, it is contained inside the modulus sign, plus constant of integration. One more thing is remaining, which is t. Let's get back to our original version. An original version says e raised minus x was assumed to be t, which has to be replaced by us. T is e raised minus x, all other things remains the same. So this is the result we were talking about, and all this let, putting, and even if you want to write that formula which we studied in the previous question, that has to be put in here. Cot x divided by log sin x. Now this is very straightforward question, because it's very clear. Log sin x, if you put it as t, you are going to get cot x dx. That is, if you write t equals to log sin x, if you put or let dt by dx is going to be equal to 1 by sin x here, and sin x will be cos x, differentiation. So you get cot x on the right hand side, dt by dx you can take on the right hand side, it will be cot x dx. So the numerator, it goes, and this will form a dt. So integration of, what do you get? Cot x dx is dt, and in the denominator log sin x was taken as t. So this integration becomes simply ln modulus of t. Log is base e, because it's given in the question log, so I'm writing log. When it's not given, always write ln, not log. Since the question is saying log, we are writing log. Now let us take the modulus of t. I'm just writing the actual thing, log sin x, just trying to get rid of one more step. And there is an intermediate step also, okay? I'll just show you. But this is the final result. So this is the solution we were talking about. All this language, English language, in order to make it understand to your examiner, you have to write it by yourself. Now this is a very straightforward question. Okay, you can just do it by yourself. Go ahead. And those who want to actually understand, let's do it in a quick manner. T equals to e raised 2x, dt by dx will give you e raised 2x. The differentiation of 2x will be 2. So this is 2 into e raised 2x. So in order to replace e raised 2x into dx, we will get dt by 2 equals to e raised 2x into dx. E raised 2x into dx, dt by 2. So the upper content we already got. Let us replace it by dt by 2. Now this is 1 by 2. I am taking it outside. Always take the constant outside. Dt is there, e raised to x is nothing but t minus 2. It's quite straightforward now. We have done a few questions like this. So 1 by 2 ln, because there is no log given. So always type ln for it. T minus 2 plus constant of integration half ln. T has to be the original thing, which is e raised to x minus 2 and plus constant of integration. This is your final result. Okay, this is what we were discussing about. See, I do it in 2 or 3 steps, but you have to write all of it, because what you write is what being understood by the other people. 2 cos x minus 3 sin x, 6 cos x plus 4 sin x. Now those who have done a question like this, they will see and they will take 3 common from the denominator. So you'll get 3 and 3 2s are 6, and you can take 2 common because you need the numerator, right? So this is a 3 cos x, and you take 2 out, it will be 2 sin x. So when you differentiate this 3 cos x plus 2 sin x, you are going to get the upper result, that is the numerator, directly. But my question is that I know it. How will you know? You are learning right now. Okay, I know everything. Most of the thing I know, because I've done it. So I will go along with you. I will not take this anything common. I will do it with what we have. That is, I'm just cancelling it out. Those who know, they can just go ahead. But I am writing without taking anything constant, just 6 cos x plus 4 sin x. This is specially for those students who really want to understand things, and they should know the trick to be understood very well before attempting this question. So just take the denominator 6 cos x plus 4 sin x. This differentiation will be negative 6 sin x, 4 sin x will be cos x. And now here, when you see 2 cos x minus 3 sin x, you need that, right? Now you can do it here, because now it's quite evident that you need 2 cos x minus 3 sin x. You can get it from here. So just take 2 outside. You will get 2 cos x. This is going to be minus 3 sin x. So this is dt, this is dx, this d2 goes in the denominator. dt by 2 is 2 cos x minus 3 sin x dx. This is dt by 2. Now what do you see here? It's the same thing which we were expecting, which we wanted to know. Alright, now you can do it. Integration of the numerator is a dt divided by 2, so half I am taking outside. 6 cos x plus 4 sin x, and this is in the denominator. You have a t in the denominator. Only there is a catch of this half. You'll see, because when I'll show you the printed result, that will be different, but the answer will remain same. Half, the approach will be different. ln, what is t? 6 cos x. Let us take 6 cos x. Don't worry about that. You will get a way to actually get it the way the book or the R.D. Sharma solution is prescribing you the result. So 6 cos x plus 4 sin x plus c. But this is not the actual result. You know why? Because when you want, because there has to be some matching. So this 6 cos x plus 4 sin x, you can just take 2 outside right now. If you keep it like this, that this is also a complete solution. I'm just saying that this is the result. But in order to match the answer which R.D. Sharma or the book has provided, we can take 2 constant from here outside. When you take 2 outside, what you are going to get? 2 into 3 cos x plus 2 sin x. So log a into b. What is log a into b? Log a into b is log a plus log b. What is log? First one log 2. The second will be log 3 cos x plus 2 sin x. Now just understand it very well. I'll show you how this 3 cos x plus 2 sin x will be the final result. Half log ln basically 2 into 3 cos x plus 2 sin x, and then constant of integration. Now just separate them out. Log, as I just indicated you, log a into b was log a plus log b. Again I am telling you because this is very important. These are the results which will come all the way, all through. So these needs to be on your tip. So just multiply this half and separate them out. Half ln 2 plus half ln 3 cos x plus 2 sin x in the modulus. And what about half log n? It's a constant. You can just add it with the final constant. Ln 2 by 2 is a constant. So you can just add it with the constant. So the final result is half ln 3 cos x plus 2 sin x plus constant of integration. So if you take t 3 cos x plus 2 sin x, this step which is log a plus log b, that you can get rid of, or that you can bypass. So this is what I was talking about. So you can take these 3 cos x plus 2 sin x only when you learn this question. You have done 2-3 questions like this. Then you are aware, oh, what to take, what not to take. But if you are not aware, then the way I told you, you can go about it. What do you see here? X square plus sine 2x plus 2x. When you differentiate this denominator, you are going to get the numerator by itself. So x square will be 2x, sine 2x will be cos 2x with a 2 also. And 2x differentiation will be 2 only. So what I am trying to suggest here is just take this denominator directly as t. When you take x square plus sine 2x plus 2x, dt by dx is going to be, x square will be 2x, sine 2x will be cos 2x, then the differentiation of 2x will give you 2, so it will be 2 cos 2x. Differentiation of 2x is going to be 2. So when you take 2 common, you will get x plus cos 2x plus 1. Now this x plus cos 2x plus 1 is nothing but what you are going to get in the numerator. So dt by 2 is this one, cos 2x plus x plus 1 into dx. This is what you get in the numerator. So how easy it has become. This is dt and this half goes here. So what you have here, you have taken already x square plus sine 2x plus 2x as the t. So dt by t, it's just half ln modulus of t. That's the direct result which we have been doing until the 26 questions. So x square plus sine x plus 2x plus constant of integration. This is your result. T was x square plus sine x 2x plus 2x. So this is the solution which you are going to write by yourself. Now this question 1 by cos x plus a cos x plus b. Now here again this is a separate question. It will not follow all the rules and regulation that we have just completed in our past 7 exercises we have done. At the 8th exercise we are on to. This x plus a and x plus b shows you something. That is, how can we make it easier? Come all things in the numerator, bring everything in the numerator, cancel things out, make it easier, and try to conclude with a very simple result that is possible in integration. I am writing cos x plus a into cos x plus b here, but I am introducing something, and that introduction is sine. Now what do you see inside? X plus b minus x minus a. What are you going to get? X gets cancelled, you get b minus a. So x plus b minus x plus a you can write, because x plus a and x plus b already we have in the denominator. So sine b minus a, multiply numerator denominator by sine b minus a. But this b minus a should be written like this: x plus b minus x minus a. X plus a, sorry. Similarly, if you have multiplied in the numerator, denominator also should have sine x plus b minus x plus a. Now you will just ask a question, why are you doing this? Why do you do this? Isn't there a simple solution? I'm afraid not. So this sine b minus a is a constant. That's why you don't have to worry about the denominator. You can just separate this out from the actual integration. Sine b minus a goes out of the integration sign. This sine x plus b minus sine x plus a is sine a minus b. Now you have to apply the formula of sine a minus b. Okay, sine a cos b minus cos a sine b, like this. So what is a here? X plus b. What is b here? X plus a. So sine a, that is x plus b, cos x plus a minus cos a sine b, cos x plus b sine x plus a. You can just exchange or change the position, it's up to you. Eventually there is cos x plus a and cos x plus b in the denominator. That is important because there will be a lot of calculation and cancellation which will take place. So this cos x plus a and cos x plus b, just put this in the denominator for both the terms which we got just now after expanding sine a minus b formula. So this cos x plus a, cos x plus b in the denominator. Integration is already there, dx is already there. Okay, don't forget about that. Cos x plus a cancelled out, cos x plus b cancelled out from first and second term respectively. Now sin x plus b by cos x plus b is tan x plus b. Similarly, sin x plus a divided by cos x plus a is tan x plus a. So these two separate terms integrate different in a way, but the result remains the same because it's just tan something dx. So what is the tan theta integration? It's log sec theta. So log sec x plus b comes here. Here log sec x plus a comes here. But you know the formula of log a minus log b. What is log a minus log b? You can always write it as log a by b. This goes log, this is sec x plus b by sec x plus a. Now you can make it easier, but I can assure you that this is the solution. This is the final solution, but just make it as cos now. Sec goes up, it becomes cos. So sec x plus a goes up, it will be cos x plus a. Sec x plus b comes to the denominator, it becomes cos x plus b. So 1 by sine b minus a is already there, was already there. So these two are the result, whichever you want. You can just stop at this one, but if you want more adventure, just do the last one also. Okay, now you understood why we have taken sine b minus a. Why did we multiply it in the numerator and denominator? Why did we write b minus a as x plus b minus x plus a in order to get this? So this is the result I was talking about. It seems typical, but not. The way I explained you, I hope you can solve these kind of question if it comes to you in the later part of your life. This is the denominator is very important here, as in the earlier questions. Just put this denominator as a t. You will see that the numerator is going to automatically come. So t equals to 2 sin x plus cos x dt by dx will be 2 cos x. Cos x will be minus sin x. What do you see? Minus sin x plus 2 cos x in the numerator. So that numerator is already there with you. What you can do? Just dx on the right hand side will make dt as the numerator. That is 2 cos x minus sin x into dx. This is already there. So just write this integral as integral sign, that symbol, and this dt will replace this 2 cos x minus sin x into dx. In the denominator, it is going to be t because that's what you have assumed. So it will be ln modulus of a t plus c. So I'll just bypass one step and I'll just write what was t. So this is going to be 2 sin x plus cos x. Don't bypass this step, okay? You have to write that step. I'll show you how to do that. So this is the solution we were talking about. Next one is cos 4x minus cos 2x, sin 4x minus sin 2x. So even if we put the sin 4x minus sin 2x, it's going to be 4 cos 4x minus 2 cos 2x. And that's not going to solve our purpose because numerator will not be formed. So we need to take another approach, and that approach is only possible when we use the formula. So the formula is very important. If you know the formula, if you can recall the formula, this question will be very easy for you. Let me write it for you. It's cos A minus cos B. And we have sin A minus sin B because A and B are 4x and 2x. So cos A minus cos B is negative 2 sin A plus B by 2 sin a minus b by 2. This you already know. Then we have sine a minus sine b. What is sine a minus sine b? If you want to recall this and write this formula, let me help you here. It will be 2 cos a plus b by 2, and this is sine a minus b by 2. So cos a minus cos b, sine a minus sine b. Then we have the integration. Let us write these two in place of cos 4x minus cos 2x and cos sine 4x minus this sine 2x. So let us write it here. So this will be negative 2 will remain there, so I am just writing it. Let us do this a plus b by 2 and a minus b by 2. So we will have 4x plus 2x by 2, and this will be 3x, and 4x minus 2x by 2, that is going to be x. So we'll use this directly here. It will be sine, what is a plus b by 2? Already done, so it's 3x. Sine a minus b by 2, a minus b by 2 already done, it's x. So you can just write sine x here. In the denominator, it will be cos a plus b by 2. What is cos a plus b by 2? It's 3x, so it will be cos 3x. And then we have sine x, so you can just cancel this sine x and sine x because they are common. 2 you can common, so you can cancel them out. Negative you can take outside. Sin 3x by cos 3x is of course tan 3x, and this tan 3x integration you already know because tan 3x has a standard result. Let us take this negative outside. Tan 3x ln modulus of, what is that? Tell me. It's sec 3x dx. Dx is already done, so just add the constant of integration. 1 by 3 will also be there because differentiation of 3x will be done and it will be put in the denominator, that you already know. Now you can just take this negative, and this sec x is actually 1 by cos x. When it goes with the power negative 1, it will form cos 3x. So you already know a log b is log b to the power a. So sec theta to the power minus 1, which is actually 1 by cos theta to the power minus 1, which will become cos theta only. So here, because theta is 3x, so you can just remove this negative sign, and it will be 1 by 3 cos 3x inside a ln and contained by a modulus sign. That's very important. So this formula is very important. If this is the key to this question, if you know and remember this formula, then you'll be able to solve it. Otherwise, it will be very difficult to solve this question. Now, this is your solution I was talking about. I am reiterating the formula again. Next is sec x divided by log sec x plus tan x dx. Now, when we place this log sec x plus tan x as t, you will see that sec x dx will automatically come. So t is equal to log, it's sec x plus tan x, and sec x plus tan x log sec x plus tan x dt by dx will be what? Log x or log theta or log whatever inside will be 1 by that thing. So 1 by sec x plus tan x. What is sec x differentiation? Sec x tan x. What is differentiation of tan x? It will be sec square x. Okay, I am going to give you that feeling that we are going to get sec x plus tan x. How? Just take this sec x outside. When you take this sec x outside, you will get, first is tan x, the second is only sec x. So what are you going to get? You are going to get the sec x plus tan x in the numerator, also in the denominator. You can cancel it. Only sec x will remain. Dt by dx is equal to sec x. You can take this dx which is in the denominator to the right hand side. The dt will be equal to sec x dx. Now this I, which is the integral, is equal to integral sine. This dt is actually sec x dx and the denominator was t only. So it will be ln modulus of t plus constant of integration. I am saving one more step of myself. I am writing directly t here. Don't bypass that step. You have to write it, right? So ln modulus of log sec x plus tan x and plus constant of integration. So this is the result. Okay, this is the result. Just assume that log x is log base ex, and that will solve your purpose. Just take t from the denominator and assume this denominator as t. Numerator will come by itself, and it will be simply log t plus c, and t, of course, what you have taken, just replace it, and that will be a solution. Next one is almost similar to the question we have just covered. So when you take this log 10x by 2 as t, you'll see that the differentiation will give you cosec x dx. So t equals to log 10x by 2, dt by dx is going to be equal to, this is log is 1 by that thing, so 1 by 10x by 2, and 10x by 2 will be sec square x by 2. And please remember that this is x by 2. So this x by 2 has to be differentiated and kept like this, half. I've kept it in front. So this sec square is 1 by cos square. Tan is sin by cos. So what are you going to get? Just cancel one cos. This sin goes up. It will remain in the denominator because it will be eventually 1 by cos square into cos x by sin x. So 1 by 2 sin x by 2 cos x by 2, because of course it's x by 2. 2 sin theta cos theta is a sin 2 theta. 2 sin x by 2 cos x by 2 is sin 2 into x by 2, which is x only. So 1 by sin x you got. Now you need this cosec x in the numerator. So you just take it into the numerator. It will be cosec x. So let me tell you again. 1 by sin x is cosec x. So dt is equal to cosec x dx from here. Now this numerator was already cosec x dx. You can just write dt in place of cosec x dx. So this integration is going to become integration of integration sign. Cosec x dx will be dt. Denominator will be log 10x by 2. And this dt by t will be ln log, basically modulus of t plus constant of integration. Let me write t directly here. That step you are going to write. So log modulus of log 10x by 2. Kindly use the brackets. It will definitely tell the examiner that these are different parts of a term, and constant of integration of course to be added. So this is the result I was talking about, we just discussed, and all this putting and note, all this you have to write. Okay, this question might seem to be a new question for you, but you see, log x, the differentiation of log x is simply 1 by x log x. If you do it once, next time this question will come to you, you will be easily be solving this question. So t is equal to log x. These are all different, so kindly try and make a habit to keep everything separated by using the comma. By the brackets. That's very important. dt by dx is what? 1 by log x. What is differentiation log x? It's 1 by x. So it's just 1 by x log x. Dx can be taken on the right hand side. So from here till here, what do you get? It's simply dt. So integration becomes this integral sign. Numerator is here. So dt, you can just replace the numerator by dt. And since t was log x, it's simply integration of 1 by t, which is log modulus t plus constant of integration. So let me write it, log modulus t plus constant of integration. The t was initially assumed to be log x. Now replace this here in place of t. It will be log x. So there are number of logs here. That's why this is the answer. So this is what you have to write actually, because explanation is something different and writing is something different. Writing gives you marks and explanation gives you understanding. Understanding is as important as writing the solution on the paper. So again, 1 plus cot x can be directly placed as t, and you'll get cosec square x dx directly. So t is equal to 1 plus cot x. When you differentiate this, dt by dx is going to be, cot x is minus cosec square x. When you have this minus cosec square x, because you need cosec square x only, so negative will go on the left hand side. So dt is actually minus cosec square into dx. Because you want only cosec square dx, negative can be taken on other side. So this cosec square dx completely becomes now negative dt. So negative you can take outside dt. Denominator is 1 plus cot t, which was t only. Again the same thing. You can just take log modulus t plus constant of integration with a negative sign. So I'm just writing the direct result now. It will be minus log modulus of 1 plus cot x. If you replace t by 1 plus cot x, which you eventually have to do, and 1 plus cot x here, and with the constant of integration. This is your answer. So this is how you are going to write. It's very straightforward. All these questions, just put the denominator as t, you will get the numerator. And log is the answer. Now this question again seems to be a different sort of question, but don't worry about that. The denominator will give you exactly the numerator. That is, if you put t equals to 10 raised x plus x raised 10. When you differentiate this dt by dx, this 10 raised x, a raised x, the differentiation of a raised x is a raised x log base ea. A is 10 here. So wherever a is there, just put 10 and keep it here. So 10 raised x log base e 10 plus x raised power 10. So it is nx to the power n minus 1. Wherever n is there, just write 10. So 10x to the power 9. So you have this result. Now what do you see? Numerator and denominator and this result are exactly similar. So you can just replace this whole numerator with dt. As you see here, when you take this content and multiply it by dx, which is coming from the denominator of the left hand side, you'll get dt. So dt, denominator is t, again the same result, log modulus of t plus constant of integration. I'm writing the direct result now. Don't skip that in between step. So ln modulus of 10 raised x plus x raised 10, and just add the constant of integration. So this is how, at first glance you might feel how do we solve this, but if you do the practice, it's very easy for you. Next, this type of question I think we have already done. So just take this x plus cos square x as t. When you differentiate this dt by dx, it's x is 1, cos square x will be 2 cos x, and cos x will be minus sin x. So I am writing negative here. 1 minus 2 cos x sin x, so you can just write it as 2 sin x cos x, which is sin 2x. Let me tell you again. Sin 2 theta is 2 sin theta by 2 cos theta by 2. That is, sin 2 theta is 2 sin theta cos theta. Sin theta is 2 sin theta by 2 cos theta by 2, and it goes like that. But here you just write 1 minus sin 2x. Take dx on the right hand side. This whole is dt. You can just write I as integration of the numerator becomes dt and denominator becomes t. So we have log modulus of t plus constant of integration. In place of this t, write x plus cos square x. So ln modulus of x plus cos square x plus c. So this is the result now. So if you have been following me, I hope that you have understood the concept now. Now this log base e. First of all, assume that log is base e, and you will see that how do we write this? Can you do it by yourself? Because it's very evident that when you put this denominator as t, which is x plus log sec x dx, when you differentiate it, dt by dx, you'll get what? This dx which is in the denominator is actually upstairs. It should be in the numerator. So 1 plus 1 by sec x tan x. Sec x gets cancelled. 1 plus tan x will directly come. So this dt is nothing but 1 plus tan x into dx. So this whole is dt only. So it's very straightforward now. We have integration. This is dt. Modulus of log modulus of t will come. So integration of dt by t, which is I equals to integration of dt by t, is simply log modulus of t. Let me write it directly. X plus log sec x plus constant of integration. Just use the bracket, that will make the examiner more happier. So this is how you are going to go about it. This is the solution, and writing is your idea. You need to write in your way. So this again question have been visited already, and we are going to do it quickly. You see sin 2x is there, and differentiation of sin square x is sin 2x only, because 2 sin x cos x sin 2x is there. So when we have t equals to sin square x, when you differentiate it dt by dx, it's 2 sin x, and differentiation of sin x is going to be cos x. So dt becomes 2 sin x cos x into dx. So 2 sin x cos x is sin 2x only. So dt is equal to sin 2x dx. Numerator is directly in our hand. So I equals to the numerator, which is sin 2x dx, can be replaced by dt, and a square plus b square t. Don't worry about the square or cube or whatever, because these are just constants. Don't worry about that. So 1 by ax plus b, a square, b square, a cube, b cube, whatever it is, doesn't matter. The result remains the same. 1 by a ln, and then the modulus of ax plus b plus c. So a b square is taking the place of a here, so 1 by b square ln modulus of a square plus b square into t plus constant of integration. One more step is remaining. T was sin square x, which we assume. Replace t by sin square x. So 1 by b square ln a square plus b square into sin square x plus constant of integration is your final result, because t was sin square x initially we assumed. So this is the final result. You need to write it exactly what I am showing it to you. This is x plus log x in the denominator, and when you see that we will put it as t, you'll get this x plus 1 by x. So this t will be equal to x plus log x, and it's all about differentiation. So this dt by dx will be equal to, this content should come as the numerator, and one part of denominator should come. So 1 plus 1 by x. When you take the LCM, it will be x plus 1 by x. So dt will be equal to x plus 1 by x into dx. So this whole is dt. Now let us take this. This integral will be integration of, this is dt. Then we have t. So the formation will be ln modulus of t plus constant of integration. And this ln modulus t, what was t? It was x plus log x plus constant of integration. This is your answer. Okay, this is the solution I was talking about. So please remember to let the examiner know that you know this log x is log base ex. Alright, here sine inverse x, the differentiation is simply 1 by under root 1 minus x square. So you know how to do this now. This is the only catch in this question. When we put t equals to sine inverse x, dt by dx will be equal to 1 by under root 1 minus x square. And this dx goes here. So you'll get this part, this part, you already got it through dt. This integral will be, this is dt. And since we are at the 40th question, you are aware that how to solve this. What is the result? So 2 plus 3 sine inverse x will be t only. When you take this 1 by ax plus b integration, you will get 1 by a ln modulus of ax plus b plus constant of integration. So this is what we are going to do here. Integration of this dt by 2 plus 3t, equate it with 1 by ax plus b. So 1 by 3 ln modulus of 2 plus 3t plus constant of integration. 1 by 3 ln 2 plus 3, what is t? We assumed it to be sine inverse x. So just replace it by this plus constant of integration. So how do we write it? So this is the way you are going to write it. Let, putting, since, all the symbols, implies is equal to sine. Please don't forget. So this one is more easier than the previous question. See, normally people would do 10x equals to t they will put. But when you see a constant, it's going to be 0 when it is differentiated. So just take t equals to 2 plus 10x. When you differentiate both the side, dt by dx will be sec squared x. So dt is equal to sec square x into dx. This is the numerator. Sec square x into dx is dt. So you get this. So integration will be equal to integration. This is dt divided by this 10x plus 2 or 2 plus 10x will be dt. So integration of ln modulus of t, ln modulus of t. T was 2 plus 10x or 10x plus 2. So now write it like this, ln modulus of 2 plus 10x plus c. So this is the solution I was talking about. So it's a straightforward one, but don't forget about this let and putting, etc. Okay, almost similar. Sine 2x will give you 2 cos 2x, 10x will give you sec square x, minus 5 will be eliminated when we differentiate it. So t will be equal to, we'll put t equals to sine 2x plus 10x minus 5. When we differentiate both the side, dt by dx is going to provide you cos 2x, actually 2 cos 2x, because the differentiation of 2x will also yield 2. 10x will be sec square x, this will get eliminated. So this dt will be equal to 2 cos 2x plus sec square x into dx. So this integration will be integration of dt, this whole numerator I am talking about, and that the denominator is already t. Now you have a straightforward solution. ln modulus of whatever comes inside, which is t only, which you initially imagine, is going to be sine 2x plus 10x minus 5. So in place of t, because the result would be ln modulus of t plus constant of integration. So I'm just bypassing one step. So this is the result I was talking about. So this is the whole way you have to actually write it. Now we have sine 2x divided by sine 5x sine 3x. Now even if you put anything of the denominator, you are not going to get anything from the numerator. Or numerator will not give you the denominator. So one reasoning can be 5x and 3x will get you 2x. That is 5x minus 3x is equal to 2x. So this sine 5x minus 3x is actually sine 2x. This numerator sine 2x, which we have written as sine 5x minus 3x, is sine a cos b minus cos a sine b. Sine a minus b formula is sine a cos b minus cos a sine b. You know already about this. What is in the denominator? Sine 5x sine 3x. Now take them separately, that is take the denominator with each term, sine 5x and sine 3x. Now just cancel those terms which are common. So you will get this cot 3x minus cot 5x. Cos x by sin x is cot x. See, cos by sine is cot, sine by cos is tan. So integration of cot 3x minus integration of this cot 5x Cos 5x by sin 5x is cot 5x. Now cot x directly you can integrate. So cot x ln and modulus of what? Cos by sin. Okay. So ln modulus of. So this cos by sin, whenever you see this p by q form, the denominator will come. Always in integration, remember that. So ln sin 3x, ln sin 5x, but 3x will be differentiated, 3 will be in the denominator, 5x will yield 5 plus constant of integration. This is your final result. So this is how you can get this. 5x minus 3x is 2x. If you can imagine that, this question will be a piece of cake for you for sure. 1 plus cot x divided by x plus log sin x. So again, let me tell you, this type of question we have already done. T is equal to x plus log sin x and is equal to differentiate. When we differentiate, 1 plus 1 by sin x log and then cos x. Sin x is cos x. So 1 plus cot x will come by itself. This numerator we are talking about, 1 plus cot x into dx. So this dt and dx we can take on the right hand side. So dt by dx was this one. When we take dx on the right hand side, so we'll put it like this. Integration of numerator is dt, denominator is t. So this is ln modulus of t plus constant of integration. So ln modulus of t is what? T is what? X plus log sin x. X plus log sin x plus constant of integration. So this is the way you are going to actually write it. See, learning and understanding is different, but writing is, you have to write every expression, every thought, whatever you do in saying someone, talking to anyone. That's how you are going to write. So 1 by under root x, 1 plus under root x. Now this, if you put t equals to 1 plus under root x, you are going to get this 1 by under root x. See, dt by dx is 1 will be 0. Root x differentiation is 1 by twice of under root x. 1 by 2 under root x, how has it come? You know already. Differentiation we have done a lot. So this 2 goes here. Dt will be equal to dx by under root x. Now dx by under root x is already there. See, this one is already there. It's 2 dt. So wherever this dx by under root x you encounter in this question, just put it as 2 dt. 2 I have taken outside. So it will be simply 2 ln modulus of t plus c. 2 ln, what was t? T initially we assumed to be 1 plus root x. Or root x plus 1 plus constant of integration. Now this is the solution. Okay, this is a different kind of question actually. But whenever 2 tan theta comes, please remember, apply the formula of tan a plus b or tan a minus b. That is what is going to give you the result. Because tan 5x can be written as either tan 2x plus 3x or tan 3x can be written as tan 5x minus 2x. So these are the combination. Tan 5x minus 2x is 3x, tan 3x. So this tan 2x plus 3x, tan a plus b, which is tan a 5x, is tan a plus tan b divided by 1 minus tan a tan b. Alright, tan a plus tan b by 1 minus tan a into tan b is tan a plus b. So what is the faida? What is the result? You are going to get tan 2x, tan 3x, tan 5x when you multiply, cross multiply these two terms. On the left and right, if you cross multiply, this cross multiplication I am talking about, tan 5x multiplied by 1 minus tan 2x, tan 3x. So I am multiplying it, tan 5x first term and tan 5x, tan 2x, tan 3x. You can write it as tan 2x, tan 3x, tan 5x. On the right hand side, it will be tan 2x plus tan 3x. Now what do you see here? You see that the question is already being formed from here. And in terms of those terms which we can integrate easily, very easily. So this tan 2x, tan 3x, tan 5x, negative sign is also there, okay? This is negative. Tan 2x, tan 3x is already there on the right hand side. Tan 5x goes on the right, so it will become negative one of this. Negative tan 5x. Okay, this negative is already there, so just take this negative on this side and you can just swap terms so that it becomes the way we are used to see it. That is, I am taking the term first to make it aligned. So this tan 5x will be ln modulus of integration. So integration of tan 5x will be ln modulus of sec 5x. 5x will give you 5, that goes in the denominator. Similarly, two negative terms are there, tan 2x and tan 3x. Let us do the tan 3x first. It will be ln modulus of sec x. And differentiation of 3x will give you 3, so it will come in the denominator. Tan 2x will give you ln modulus of sec 2x. And what is the differentiation of 2x? To be 2. So this is a kind of different question. You must do it once so that you understand that how to do the question like this. 1 plus tan x into tan x plus theta into dx. Now this is also a different kind of question. But do remember that this tan a plus b formula we have just used. Tan x plus theta is tan x plus tan theta divided by 1 minus tan x into tan theta. Okay. Now tan theta is a constant here. So it will be multiplied by tan x. You have 1 plus here also. Now multiply this tan x inside. Now you'll see what do we get. We'll get some cancellation in the numerator. So just take this 1 minus tan x into tan theta here. 1 minus tan x into tan theta. Then the cross multiplication. Tan x into tan x will be tan square x, and tan x into tan theta will be tan x tan theta. So tan square x plus tan x into tan theta. Denominator will be, when you cross multiply, so this tan x into tan x gave you tan square x, and tan x into tan theta gave you tan x tan theta. Denominator will give you 1 minus tan x into tan theta. What is the use? These two gets cancelled. And also 1 plus tan square theta is sec square theta. Sec square theta is 1 plus tan square theta. So you can just replace this 1 plus tan square theta by sec square theta. So numerator becomes sec square theta or sec square x, not theta. Sorry, I must correct myself, because here tan theta is a constant, tan x is a variable. So sec square x dx divided by 1 minus tan x into tan theta. Alright. Now tan theta is constant, so don't worry about that. Tan x will give you sec square x. If you put tan x equals to t, this dt by dx is going to give you sec square x. So dt becomes sec square x dx. So what do we get? Numerator is already dt. Denominator is 1 by 1 minus t into tan theta. Now don't get confused that tan theta is there, because just assume tan theta is some a or b. It's a constant. I'm reiterating again. Don't get confused by this tan theta. It's just a constant. I'm just saying 1 by ax plus b. The integration is 1 by a ln modulus of ax plus b. If it is 1 by ax minus b, it will be 1 by a ln ax minus b. If it is 1 by b minus ax, in the case, see, 1 minus t tan theta is almost equal to 1 by b minus ax. So it will be minus 1 by a ln modulus of b minus ax. So just assume it to be b minus ax, b is 1, a is tan theta, x is t here. Because t is a variable, because we have taken t as tan x. It was all initially x. We assume t to be tan x, so we have introduced t, which is a variable. So again, negative will come, as I just suggested you. So there will be a negative, okay? 1 by a will always be there. What is a here? Tan theta. It will be negative, because negative is there. It's just 1 minus t into tan theta. You just differentiate it by t. You will get what? Whatever you get is to be kept here. You will get a negative. So negative 1 by tan theta, and the log will remain like that. Ln modulus of 1 minus tan theta tan x, because t was tan x. So it would have come 1 minus t into tan theta. I replaced t by tan x. So that is why we have 1 minus tan x into tan theta plus c. Now this is your answer. You can just stop here. But if you really want to go ahead, let me tell you, minus cot theta into ln 1 by 1 modulus of 1 minus tan x tan theta plus constant of integration is your final result. But you can just take this sin tan x as sin x by cos x, tan theta as sin theta by cos theta, and whatever result comes, you can just make it easier for the user or for the examiner to understand. But let me reiterate once more. Okay, this is the answer. The penultimate line which I have written is the final one. So tan x will be sin x by cos x, tan theta will be sin theta by cos theta, and a negative 1 as the power or as the exponent will take this 1 minus tan x into tan theta in the denominator. So 1 minus tan x tan theta comes in the denominator. So 1 minus sin x by cos x, and this is tan theta sin theta by cos theta you can do. You can do all the cross multiplication in the denominator. The numerator will go up, and whatever is the result, you can just replace this in place of 1 by 1 minus tan x tan theta. So this is just for you to complete the question. I'm just saying we have already got the answer. So whatever I'm doing right now, some people may just skip, because this is just a way of writing the answer, because the integration has already given you the answer. The examiner has not told you that integrate and then simplify. No, they have just given you an integration sign. Integration once done, you are done. But in r.d.sharma, whatever is the answer, we have to get it. So just take this 10x as sin x by cos x, tan theta as sin theta by cos theta, resolve it, and the final answer, let me write it. Okay, I am writing the final answer here. It's cot theta ln modulus of cos x, from here we got cos x by cos x plus theta plus constant of integration, and this constant of integration is actually a capital one, because when you solve this 1 by 1 minus tan x tan theta in terms of sine and cos, you'll get a constant term also, and that constant term can be added with a constant of integration in order to get a new constant of integration, which is c dash, you can say. Alright, let me show you the result. This is your result we are talking about. So till the third step of the right side block, the answer has already come, then we resolved it. This is sin 2x divided by sin x minus pi by 6 sin x plus pi by 6. Now sin pi by 6, let me tell you, it's 1 by 2. Just in case we encounter and we come to a point where we have to use it. Now the denominator is sin a plus b and sin a minus b. You can also call it as sin a minus b into sin a plus b. Simply sin square a minus sin square b. You already know that. This is a standard result. So integration sign and dx will always remain. I'm not writing it. That doesn't mean you will not write it. You're going to write it all the time. This is just for your explanation or understanding of the logic. Sin 2x is in the numerator. Sin a plus b into sin a minus b will give you sin square a minus sin square b. This is sin square x minus sin square pi by 6. I told you sin pi by 6 is half, because sin 30 degree we are talking about. Sin 30 degree is half. Half square is 1 by 4. So sin square x minus 1 by 4 in the denominator will come. Okay, now it has become so easy. Sin square x will directly give you sin 2x. That you already know. So that is what we are going to use. Sin square x minus 1 by 4. You can take all the denominator as t. dt by dx will give you 2 sin x cos x. This minus 1 by 4 will just get eliminated. dt will be equal to 2 sin x cos x is sin 2x. Sin 2x into dx. So the numerator is already there with us. This integration will be dt divided by sin square x is going to be equal to, because that was sin square x minus 1 by 4 totally we have taken as t. So integration of this, you can just directly write it ln modulus of t plus constant of integration. In place of t, just replace it by sin square x minus 1 by 4. So it will be ln sin square x minus 1 by 4 plus constant of integration. This is your final result. Okay, this is the result we are just talking about. This sin a plus b into sin a minus b is very important here, right? Next one is e raise x minus 1 plus x raise e minus 1 divided by e raise x plus x raise e. Okay, let us take this denominator as t. So e raise x plus x raise e will be t. dt by dx will be what? E raise x remain e raise x. X raise e, actually x raise e is equivalent to x raise n. So when you differentiate x to the power n, it will be nx to the power n minus 1. So this will be e x to the power e minus 1. E x to the power e minus 1. So there are two ways you can do it. Either you take this e, that is x raise e minus 1 divided by x raise e minus 1 will be x raise e into x raise minus 1 divided by x. This is one way. The better way is to divide everything by e, because we need x raise e minus 1, we already got. But we need e raise x minus 1 also. So e raise x minus 1 will only come when you have this divided by. See, whatever I am doing, I am just trying it out. These are the trial and error method everyone has to follow, because every time you will not get the answer directly. So what I am suggesting here is just divide everything by e, because that I perceive already what are we going to get in the numerator. So I divided everything by e. So I have to divide the e on the left hand side also. So e raise x divided by e will give you e raise x minus 1. Here e gets cancelled, so the x raise e minus 1 remains. 1 by e is there, so dt by e is equal to the numerator already. So this numerator is simply dt by e. So you can take it as dt. 1 by e you can take it outside. T is in the denominator. When you integrate it, it will be 1 by e ln modulus of t plus constant of integration. T was taken as x raise e plus e raise x, or e raise x plus x raise e. So 1 by e ln modulus of e raise x plus x raise e plus constant of integration is your final solution. So this is the solution I'm talking about. Let putting all the symbols, the since sign and the therefore sign and the all written material, the content should be like this. So 1 by sin x into cos square x dx. Now please understand this question, because the next question is exactly like this. So sin square x plus cos square x, wherever we see sin square x, cos square x and a 1, we tend to write 1 as sin square plus cos square because sin square plus cos square is 1 only. So this sin square plus cos square divided by sin x cos square x will become sin square x remain in the numerator, sin x into cos square x goes in the denominator. So this sin gets cancelled. This is sin by cos square. So you can write it as sin x by cos x into 1 by cos x. Sin by cos x is 10x, 1 by cos x is sec x. So this sin by cos can be written as 10x. 1 by cos x is sec x. So we have a term which have direct integration. First term we have got. Now what do you get here? You can just cancel this cos square 1 by sin x. When sin x goes up, it will form cosec x. So we have to integrate these two now. Just write that dx term and integrate it. We don't have to put anything as t here. Sec x tan x has a direct integration. What is integration? Sec x. Cosec x is what? ln modulus of cosec x will be cosec x minus cot x. It will be cosec x minus cot x plus constant of integration. Now you can make this cosec x minus cot x more simpler. Cosec x is 1 by sin x. Cot x is cos by sin x. So 1 by cos by sin. So this is tan x by 2. You already know that this is equal to tan x by 2. So in place of cosec x minus cot x, you can also come up with this tan x by 2 if you want. So these are the standard result. So sec x plus ln modulus of tan x by 2 plus constant of integration is your answer. So this is the result we were talking about. Please remember, wherever we have sin square cos square involved and 1 is there, always take 1 as sin square plus cos square x. That will give you certainly some result. 1 by cos 3x minus cos x. So cos 3x and minus cos x. See, cos 3x is what? It's 4 cos cube x minus 3 cos x. You already know this formula. Without this formula being known, very difficult to attempt this question. So this cos, when we write cos 3x, since we have to equate it with cos 3x minus cos x, so this will be 4 cos cube x minus 3 cos x minus cos x, and that is going to give you 4 cos cube x minus 4 cos x. So I'm writing the denominator as 4 cos cube x minus 3 cos x minus cos x will become minus 4 cos x. So you can take 1 by 4 cos x common if you want, because it will give you certain result. You will just see. When you take this 4 cos x common, it will be cos square x minus 1 inside. And cos square x minus 1, you know that sin square x plus cos square x is 1. So what is cos square x minus 1? It's equal to minus sin square. 1 minus cos square x is equal to sin square x. So cos square x minus 1 will be minus sin square x. So 1 by 4 cos x, this cos square x minus 1 will become minus sin square x. So 4 is already there, negative is already there. So what do we get here? Negative 1 by 4 and integration inside you will get. So it's 1 by cos x into sin square x. Now what is the similarity? See, in this question number 50th we are doing, and I'm doing and solving it in this question only. See, we have 1 by cos 3x minus cos x, remember? So now I'm just trying to equate it. So in place of 1, write sin square x plus cos square x, and cos x into sin square x is already in the denominator. So this will give you some cancellation. So sin square x gets cancelled, cos x will be sec x, and this you can cancel 1 cos, and this 1 cos by sin into 1 by sin. Cos by sin is cot, and 1 by so cos by sin is cot. It is cosec x because 1 by sin x is cosec x. So cosec x cot x you got. Sec x plus cosec x into cot x. So negative 1 by 4 will remain like that. And integration of sec x and integration of cosec x cot x will be done. So negative 1 by 4 is still there. We'll just introduce it in a short while. But we have to integrate these two terms. Sec x has a direct integration ln modulus of sec x plus tan x in the modulus. Modulus means absolute. Only the positive will come inside. And this cosec x cot x is already minus cosec x, a direct solution. So plus constant of integration you can do. Minus 1 by 4 is already there. So just multiply everything by minus 1 by 4. So 1 by 4 will remain like that. And if you multiply negative inside, you can just swap these two terms. It will be cosec x minus ln modulus of sec x plus tan x. And then we have the constant of integration here. This is your final answer. So this is the result we were talking about. It's straightforward now. Previous question is this one. We have done just this one. So this is how we have related with the previous question. That's how questions are interdependent actually. So this is all about this exercise. We have completed this one. Have a good one. Take care of yourself. Don't bother about subscribing or liking. It's up to you. Just learn.